So it was from back when you guys were in like second grade, maybe.
Well, for me,
But,
it wasn't until I was
so I was teaching back then, right? I was teaching back then, so I decided around this time I bought a penguin costume.
Is this the first year? Like you're going through this?
No, that's what I'm saying right now. Is I've like now it's become a reward, right? But back then it was just for Halloween. I just dressed up as Gigi. But now you guys reached $13,000, and not only is Gigi going to be here, but DJ Hudcap Gigi, DJ Gigi. I don't know. We'll figure out the name. But so, yeah, be here tomorrow. All of that to say, be here tomorrow. Anyone need help getting logged on? I'm waiting to see. Like Lindy, looks like we're still waiting for you. Lily, looks like we're waiting for you. Ivan, you getting in? Raphael, you getting in? Alright, so then we don't need to be chatting with each other. We need to be typing our thoughts into the desk.
Oh, wait, we can remember this together.
What do you mean?
I don't understand.
So, alright, so Jana is saying that she'd like a bit more explanation on the question. So, Kiri has collected all of this information about animals and their speeds, right? Because it's slide 5. So we made some predictions, right? Which is faster. So if I go back and I look at our predictions, we were split on mouse elephant, right? And I have you guys anonymized right now because I'm recording. We agreed horse versus raccoon. We agreed dolphin versus hedgehog. Right, and then we started to talk about now we were very split here. But we started to talk about why we thought bigger animals might be faster or not. So there was yes, no, or I don't know. And I love, one of you complained there was no sometimes option. Right, one of you was like, well, I want to say sometimes, but that's why I said I don't know. So we've got that. So now we're here where the graph's kind of broken. Now, if we just say we can ignore this, what do we call a point that's like really far away from all the other points? Anyone know? What? Outlier. So if we go ahead and say we're going to ignore the outsider. If we are going to ignore that point, what could we do to fix this graph and like spread these points out a bit? So write your responses in here, then move on to 6 where we get the like chance to fix the graph. All right, so keep working. I'm going to pass out stuff that was turned in, and then our next homework.
Oh, wait. What were we supposed to turn in tomorrow? I mean, yesterday?
Nothing got turned in yesterday. It all gets turned in tomorrow. Well, I don't know. I think mice come in different sizes.
Yay!
So if you come to math lunch, we can get this done. So when you took this on the question mark, so we can finish this problem of it. The 4 turns into 20. What would the 3 turn into? 4 turns into 20. So we just need to finish that real quick. I could read this last night, but for some reason I just struggled to read it right now. What is going on with the Chrome? Forever. I know. Was yours totally dead? Is that what it was? Should we go plug that in right now then? There we go. So guys, I can see that 5 of us are on this slide. What we're doing is we're giving a least value for each axis and a greatest value for each axis, which right now, even though you might be tempted to say the least value is 0, it's not, because it goes to the negative. Even though we don't use the negative, it's kind of nice to have a little extra buffer zone. But are each of these squares 1? No, because like this is a really big number. So to get to that really big number, they must have a really big scale happening here. What we're trying to do is fix this. And guys, remember, there's no risk. Just throw in some numbers, hit try it, see what happens. Hey, and you will need out this resource page in a couple minutes. So if you catch a moment to like get something out of your binder, get out the resource page with the rectangles. If you have lost it, I have a few extras, but we'll get to that. Well, if you just put one square root, it's not going to spread anything. So you need a lower and a higher. Lower and higher.
Is this the one you want to?
This is tonight, 2, 3, 1. It's not due till next week. Oh yeah, that one with the rectangles. Yep.
What movie?
Wednesday. That's the name of the movie.
I'll give you the crumble that one. Hey, I don't know if you saw me or if you were in the
Is it animated?
No.
Wait, it's coming out on Netflix?
Yeah.
Hey, this conversation doesn't sound like we're talking about the math of what animals would be faster. All right, so guys, let's come together real quick. So if we ignore the outlier, right? Everyone look at this slide. I see 10 of you on there. Let's try to get all of us on here. The least value, I'm not really going to determine until I choose my biggest value. Do any of these points, anyone got suggestions for me, actually? I should really ask. Anyone got suggestions for a greatest value of how high you want the axis to go up to? 40,000?
Oh, I did 40.
Just 40? Okay, and
I
then
don't
what?
think it worked though.
It didn't work though. Okay, so maybe we should try something different then. What? So
40,000.
what is, guys? What's this number? 5,000? 5 million? 50,000. Guys, look at this number. This is 50,000. Do any of my animals even come close to that? No, we don't need to go to 20,000. I don't know what animal this is, but we can ignore that. So if this is 50,000, could we figure out what each box is worth? Also, if you click on the graph, a lot of times it will like tell you what the point is. Yeah, so you can't break Desmos, and the more you play with it, the more you realize like, oh, that's cool. So if I make my maximum, let's just do the 50,000 that they have. Everyone try 50,000 as a max. And maybe, what could we make the minimum? Negative something. Negative 6? Like just 6? I'm just at, because this was 50,000. I was just checking that you weren't meaning like 6,000 or something like that. Least value on the, well, how high does the Y's go? It goes to 30, but yeah, Christian, it goes to a little over 20. What is this dot at? We could click it. Oh, the Y's at 22. So guys, go past that. What if we just go to like 25? At a least value, I'm just going to try that negative 6 again. And then the graph changes and zooms in. So I don't love how this looks, right? That the y-axis isn't really visible. But I also don't love how much empty graph we have. Guys, play with tweaking these numbers that we just talked about. Tweak those even further. I think I want my negative to be bigger. So then it reset the graph, right? When I try again, it resets it. Negative 600. Should I change my max? 1,000. Y-axis, okay. Ah, now my points are spread out a little nicer. I could tweak it even more. Can we now tell, like, how heavy the heaviest animal is? So I could also click on it. How high do I need to go, really? 520. So let's just go, like, 550. And then now my negative probably doesn't need to be so big. Maybe, like, negative 100. Now that is a whole lot nicer. So guys, the reason that we're playing with this in Desmos first is it's way easier to tweak and change and see it and then like come back and make another tweak versus what's on your paper, but that is what we're about to do. So, the moment when you all hate me, grab your resource paper, grab your paper that I just handed out for today, and let's talk about Peyton's bats. Anyone want to read? Well, come on, it's almost Halloween. It's like the spooky season.
Oh, I think it's like baseball.
It's spooky season. Ivan, do you want to read about Peyton's bats? So it's on your paper. It's on your paper. Hey, everyone should make sure you have your name on your paper right now.
Can I read it?
Ivan volunteered to read, so we will listen to Ivan. Hey guys, that means you're not talking, you're listening. Are you wanting to read, Ivan? That or June can if you're digging for a pencil. If you don't have a pencil, though, we'll give you time. June, go ahead and read.
Okay, so do you want me to read 2 to 106?
Yep.
Peyton's bats. Peyton loves bats. She wants to know if she can predict the wingspan of a bat by there's a hole in front of the knowing the length of its body. Peyton looked up measurements for 5 species of bats. For each species, she found the typical body length from the head to tail, and the wingspan from the tip of one wing to the tip of the other. She organized the information in the table below.
So, we're going to use that table and the graphs on the back of your resource paper. Oh, Gabe. You didn't expect me to be planned out. I feel like you're throwing shade at me.
I didn't expect the research papers to be able to back.
So, Maddie, I'll take that as a compliment that, like, guys, I do not like using paper. Alex. Now, some of you are like, you know, probably thinking I'm lying through my teeth because I use paper all the time. But I don't like using more paper than I need to. So when I make a resource page, I try really hard to make it front and back. So I appreciate that it seems like most of us kept track of this. But if you don't have this, you need it. So raise your hand if you need another copy of this. It is the paper with the rectangles on it. We've been using it the past 2 days. We all got this in front of us? All right, so look at the table of our bat data. Maybe we could call it BATA. So how if we go to put these points on the graph, how will this look here in what now in 108? What are we kind of missing? And it's really the fault of the copier. We can see numbers. Yeah, we don't see the 0. Yeah, the axes aren't very dark. So guys, let's all fix the printout because I mean it's kind of the printer's fault. If you want a ruler, you could go grab a ruler. You might have one in your binder. But guys, be careful. Hey, count back from 5 to get to your 0, right? 5, 4, 3, 2, 1.
Oh, I didn't even realize there were actually ones.
Yeah, and I'm actually going to use like a colored pen. You guys could grab a highlighter if you wanted for your axes, I guess.
I'm just afraid it'll bleed through.
Well, it's okay because we don't really need the other side of this resource page much more.
Oh, yay!
Hey guys, go ahead and do that for all 4 graphs. You can see the arrows down here. You can kind of see where the axis was supposed to be. So see these arrows? Guys, look up at the screen real quick if you need. See the arrows? They come together to be our axes. And we can go past 0, 0. So if I trace down from the arrow and trace over from the arrow, we're looking for these little arrows. So guys, part of making graphs will be to make our axes first. Because without our axes, we can't really have a graph.
I did a job.
Can I have another copy? I just messed up mine.
Well,
Go to the next round.
I messed it up, but you can just go up, like, to where you
Drew it in the wrong place or something.
I just went too far.
Bell has to pause.
So this graph is still missing stuff. Right? If we look at that top left graph, it's got the points on it. So the y, ooh, that's a good point that we should probably label the x-axis and the y-axis. So like Christian just brought up, guys, let's put, and which one's the x? Is it the horizontal or the vertical? Horizontal. So this is our x-axis. This is the y-axis. All right, it wouldn't be math class if we didn't use random cards. That woo sounded an awful lot like a boo.
Yeah.
Nate, do you know what else our graph is missing? Totally fine. Addie? What our graph is missing? Ooh, there's no title. So what could we title our graph? Addie, it was weird. You like threw your voice across the room. It almost sounded like Jana.
Oh, I thought it was someone over there.
Because I called on Addie, and then you jumped in and answered. So what could we title this graph? Well, okay, that's just so you know what we're doing. But we're talking about Peyton's bats, right? Or types of bats. This table title is type of bat. But what is it hold on. What is it comparing? Length and wingspan. So, like, it's not just type, it's length and wingspan. Wait. Length and wingspan. I feel like these titles go somewhere specific. Lindy? Oh, these are our axis labels. Well, guys, check out which one you think is which. All the lengths are 5 or less. So if I look over here, which axis uses the numbers 5 or less? Well, no, look at the y-axis. We're up at 10. We're up at almost 15. So our x-axis is what uses 5 or less. So we're going to label the x-axis length. And in parentheses, we put the units that we're talking about. Guys, I see some people who either maybe already did this or are choosing not to. Choosing not to would be a risky decision. So if this is length, what is the other axis? Wingspan. Be careful. You guys fell in the trap of saying width. It's wingspan, which is actually a really cool board game. I'm not joking. There's a game about birds and where you essentially build birds. Yeah, if we play it tonight at game night, I'll take a picture and I'll bring it to you guys. So, all right, length, wingspan. I mean, this problem is called Peyton's bats, so maybe we just name the graph Peyton's bats, or I guess bat data. Like, I don't know what this is showing bat data. Bat data. Now, this graph is broke. Now, okay. Well, I was going to say broken, but I mean, so this graph is okay, but it's like when we're progressing, like that's like okay, but it's not great, right? We want to move past that. This graph is progressing because it's got all of this space that it doesn't need. And quite frankly, to me, that's a waste of paper, right? Like we were just talking about trying to be efficient with the paper. So over in 108, what Peyton suggests is, what if I flip my axes? What if instead of length here and wingspan there, what if now we put wingspan down here? Actually, wait, let me double check that I'm reading 108 right. Because I haven't done this lesson in a minute. Wait, hold up. This is a moment when I'm progressing. I shut my binder earlier and should not have. It's a good day. Hey, those of you that are just chilling and patiently waiting, I really appreciate that because I just want to make sure we do the right thing. Sorry, that's why I double checked because I reacted too quickly. Peyton is still going to keep length down here. So sorry if you went ahead and labeled real quick. Go ahead and change it back. So length, she keeps on the x-axis. Now, this is the dangerous thing about when classmates try to help you. Now, normally a good thing, but Peyton's classmate said, oh, I see what's wrong with your graph. Your scale is wrong. We need to change your scale, and that'll use more graphs. So Peyton's like, okay, sweet, thanks. Walks away, right? Doesn't actually keep getting help from that friend who told her what to do. And Peyton changes her scale. So let's graph. So her y-axis stayed the same, right? Her y-axis stayed the same. But so let's graph these bats, right? So 5, 14. Let's find, well, if that's 10, 1, 2, 3, 4, 5 boxes is 10. So every box is like 2, right? So that would be worth 2. 5, 10. It's like right up there. Guys, I'm not going to show both of these. Actually, I'll just put it up on the smartboard while you guys get a little head start. So here's our data. You guys don't need to be waiting for me. You can 100% do this without me. So 514. See, look at that. I'm messing up already. 514. 3.510. 2.3512. 411. Guys, I don't know about you, but I'm starting to get suspicious that this didn't do anything. So Peyton's friend told her, change the scale. Did that work? No. Christian, what'd you say? Say more. Say more. It made it worse. I agree. Say more. It's compacted even more than it was before. The wasted space, there's even more of. Right? And you can grab a highlighter if you want and like kind of point out like there's even more wasted space. All your points are graphed over in this tiny little sliver, and all of this space is unnecessary. So we're gonna fix this. Down here, we should already have our axes drawn. I want you to talk with your partners about how should we scale the x-axis. And we could change the y-axis scale. I don't have a huge issue with the y-axis scale, but we could change that if you want. But definitely figure out what you want to change with the x-axis. Maybe start that conversation with like, how far do we need to go? How many boxes do we have to work with? Chat with each other. Take a couple minutes and then try it out. So we're still going to do length. X-axis has to be length. What's the biggest x we actually have to get to? What's the biggest x that we actually have to get to? Like if it's length, what's the biggest x? So we can get to 5. How many boxes do we have across the screen? From like that axis across the screen.
Well, we should do 5 then.
I would be real nice. So maybe 20 might be nice. Or one. So we can just ignore the last 2 boxes. Like make it nicer, right? Like make the math a little nicer.
I'm confused.
15. Yeah, I know. No, because it goes up to 14.
So guys,
Are we talking about the
Highest number goes up.
guys, when you're confused is when the learning is actually happening, right? If I just like try to open up your brain and dump information in, it won't stick. Like it will not. A little bit of it might, but confusion is how we figure stuff out. So let's go ahead and label above this axis. Let's just put an X, or sorry, this column, and let's put a Y. What is the biggest X we have to get to? 5. On our x-axis, if I just put 5 boxes in, that's silly, right? Because that's what we did up here, and that was a waste. So count how many boxes we have across here, and Gabe went ahead and told me he thinks it's 22 boxes. What number is nicer than 22 if we're working with 5? 20. Is it, so if we're going to go ahead and say, I want to use as much of this as possible, take the number of boxes, so guys, somewhere, maybe like down here, take the number of boxes, put it over the number we want to get to, right? So we want to get to 5 inches. So we can now reduce this down. So I'm trying to let this focus, but I don't know if it will. 20 over 5 can reduce to what? 4.
4 boxes is the number of 1.
So every 4 boxes is 1 what? Inch. Hey, look, more proportions, like I said, this entire class is based on. So 1, 2, 3, there's my 1 inch. Another 1, 2, 3, 4. So every 4 boxes, right? Every 4 boxes. So another 1, 2, 3. It's over on the wall, bud. They put it in a silly place. Over there by Alex, actually. They put it in a super silly place. I don't know why.
I said somehow that I didn't. Oh yeah, I forgot the number 3 existed for some reason.
Number 3 is kind of important, especially if we're trying to like count to 4. And guys, we might as well just not mess with the y-axis on this one. So go ahead and do the y-axis the same that they had, right? And what had they done with the y-axis? How's it scaled? It's 1 to 1, right? This axis is scaled 1 to 1 because 5 boxes is 5. So 3, 4, 5, 6, 7, 8, 9. And now graph your points on here. Same data table, right? Peyton's bats. Now graph it on there.
Oh, I did that wrong.
Guys, I'm waiting for you. You're not waiting for me. I'm waiting for you. So to graph 514 now, right? We come out to 5, come up to 14, and now automatically I can see that this graph is better because we're using a lot more of the graph space. Right? We are. We're big brain. Well, check your... So 514, we scaled this axis 1 to 1. So I'm going 14 boxes, right? So hopefully if I draw over from 14, yep, there we go. So our next point, now 3.5 is easier to find, right? Because now I can actually see between 3 and 4. So 3.5 right there, up to 10. Ooh, those look like they kind of make a line with it. Well, any 2 points make a line, I guess. 4.25, also easier to find now, because I can go 4. Well, since I made every 4 boxes 1, I know 1 box is actually a 4th, right? This is 4 1/4. And that goes up to 12. Four goes up to 11, and now it's a lot less crowded over here. 3 goes up to 10. Now, anyone, ooh, I'm missing something. Crap, who can tell me what I'm missing? Well, I got my y-axis, right? If you, like me, forgot your y-axis label, put it on there. Wingspan. Gonna text Dave and tell him I want to play Wingspan tonight. Like my best friend. Randy was my best friend, then he moved to Texas.
Yeah, I had a best friend that moved to Minnesota.
I'm sorry.
I had a best friend who moved to Oregon.
See, all of this to say, like, it doesn't stop when you become an adult, right? Like, you got friends, and if they move, it's sad. So wait, like we said, well, like I said earlier, it kind of looks like these make a line. Grab a ruler or something, right? Another piece of paper you could even use. Let's make a line. But hold on. If a bird, hold on, silly, weird. Oh, bat, sorry. If a bat, sorry, the Wingspan game is all about birds. If a bat was 0 tall, or long, I guess they're calling the bat, but they're calling it length. If the bat was 0, what would its wingspan be? 0, because that bat doesn't exist. Right, so we know 0, 0 would also be on here. Let's draw a little line, kind of try to hit most of your points. Guys, have you in science yet done line of best fit? So this, as we draw a line and try to hit the points, that's what we call a line of best fit. You'll be doing this in science this year as well. So this is your little intro to, oh, okay, that's gonna come back around in science. And the reason that we draw lines of best fit are, what if Peyton is actually like a bat researcher, and now she's trying to answer some questions about these bats, and now what she gets given is a what kind of bat? A vampire bat. So a vampire bat, we want to see how scary is this vampire bat actually going to be. Its length is about 2.75 inches. Its length is about 2.75 inches. So its length is 2.75. Can we find 2.75 on your graph? Yeah, that's right here. If we wanted to predict how big the bat is, like how big its wingspan is, how could we do that? I mean, this is 2.75 inches, but that doesn't tell me wingspan. Oh, go up till we hit the line, okay.
And then the number this way.
Oh, and then go this way. You guys, you could draw this on your graph, like with a highlighter, with your pencil. So what's our prediction for its wingspan? 8, right? So 8 inches would be our prediction. So don't worry, Margot, it's only like this big. It's coming to suck your blood.
Well, like,
What? You were doing like cold chill things. Wait, is there another one? Wait, This kind of sounds cute. The Kitty's hog-nosed bat, also called the Bumblebee bat. Guys, it is only 1 inch long. Use your graph. Hey, use your graph. Use your graph. 1 inch. Go up to your line. Go over from your line. What's your prediction for the little Bumblebee bat?
Wait, no, that's not
Why did you have to go there? Why'd you have to take it there, Addie? You said it's cute till it flies into your ears. Alright. This make a little bit of sense?
Yeah.
Like a wee bit? Sweet. Pack up your papers. How, what? Well, I just meant because it's small. But what, did you search up Bumblebee bat? Alright, I'll Google it so you guys don't all have to.
It's like a bug.
He's so cute. It kind of is.
Alright. Bumblebee bat.
It's kind of scary, not gonna lie. He's so cute.
Oh, come on. Look at that. Look at how small it is.
I want one. Some of the pictures are really cute, but some of them are like,
Oh, come on. Alright, clip your papers in. Get out of here. Have a great day, guys.